Good morning, students. So we are discussing the chapter 4, pair of linear equations with two variables. So far we learned 4.1 and 4.2, and now in this class I am going to teach you relation between coefficients and nature of system of equations. Relation between coefficients and nature of system of equations. So before going to this topic, when the two lines are drawn in the same plane, the three possible situations are possible. So there they may intersect at a point. This is the first situation, and the second situation is they may not intersect. They may not intersect. They may be parallel. And third situation, they are coincident. They are coincident. Actually, both the lines are same. Both the lines are same. So, why I am explaining these situations is, so generally, how do we know when the two lines are intersecting? How do we know whether two lines are intersecting? When is the two lines are parallel? When they are constant. So we have a method by taking the two equations and by preparing the tables for them, and finally plotting the points on the graph and then joining the points. So by drawing the graph, finally we can say that they are intersecting, they may be parallel and they may be coincident lines. So this is a big process. So by using relation between coefficients, so we can easily understand nature of system of equations. That is, whether they are intersecting, they are parallel, so whether they are constant. So that's why this we have to use, by using relation between coefficients, we can easily understand the nature of system of equations. So let us learn what is the relation between the coefficients. So first relation is, so first of all, consider a system of equations. System of linear equations two variables, that is a1x plus b1y plus c1 is equal to 0. This is equation 1, and a2x plus b2y plus c2 is equal to 0. c2 is equal to 0. So this is equation 2. So clearly a1 b1 are the coefficients here. C1 is constant. Now here a2 b2 are the coefficients and c2 is the constant. So now first case, if a1 by a2 is not equal to a1 by b2, if a1 by a2 is not equal to b1 by b2, this is the first relation between coefficients. So if a1 by a2 is not equal to b1 by b2, then the two lines are intersecting at a point. The two lines are intersecting at a point. The two lines are intersecting. So that is intersecting at a point. Intersecting at a point. And now second. So two lines intersecting at a point. In this case, that point is known as a solution. That point is known as a solution of a system of linear equations in two variables. So clearly, they have a solution. They have a unique solution. So they have a unique solution. They have unique solution. They have unique solutions. So in this case, we can say that the two lines are constant pair of linear equations. Constant pair of linear equations. So, otherwise, we can define that the two lines are said to be consistent if they have a solution. So, in this case, the two lines are consistent pair. Consistent pair of linear equations equivalent or independent pair of linear equations in two variables. So let us go to the second relation between coefficients. So second relation is A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. In this case, the two lines are not intersecting the point. They are parallel. They are parallel. So, like this. Parallel. So clearly, if they are parallel, no solution, as they are not intersecting at a point. As they are not intersecting at a point. So they have no solution. They have no solution. They have no solution. So if they have no solution, so we can say that the two lines are called inconsistent pair of linear equations. Inconsistent pair of linear equations. Inconsistent pair of linear equations. So in this case, clearly we can define that the two lines are, or otherwise the two lines are said to be inconsistent. They have no solution. They have no solutions. So, and this is the second relation between coefficients. So let us go to the third relation between coefficients. The third relation is, so A1 by A2 is equal to B1 by B2 is equal to C1 by C2. If A1 by A2 is equal, B1 by B2 is equal, C1 by C2. So in this case, the lines, then they are coincident. They are coincident. They are coincident lines. Coincident means actually both are same. So coincident like this. Coincident. So coincident, they are coincident lines. Now we can, in this case, coincident lines. So actually both are same. Both are same. So if both are same, they have infinitely many solutions. 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 So clearly they have a solution. They have a solution. So if they have solutions, we can say that these are consistent lines, consistent pair of linear equations in two variables, consistent pair of linear equations in two variables, consistent pair, atilo, consistent pair, consistent pair of consistent pair. Or in this case, A1 by A2 is equal to B1 by B2 is equal to C1 by C2, then they are constant lines. So they have infinitely many solutions. So if they have a solution, we can say that they are constant pair of linear equations in two variables. Or otherwise, in this case, if they are constant, they are dependent. They are dependent pair of linear equations. Dependent pair of linear equations. Dependent pair of linear equations. So by using this relation between coefficients, we can easily understand the nature of system of equations, such as whether they are intersecting, whether they are parallel, whether they are coincident. So, and also how many solutions they have, they are consistent, inconsistent. So by using this relation between coefficients, we can easily and understand the nature of system of equations. So let us do some problems using this concept by using the these relations between coefficients, these three relations between coefficients. By using them, let us do some problems. First one is question is, check whether the given pair of equations represent intersecting, parallel or constant. So this is nothing but clearly he is asking that find the nature of system of equations. Find the nature of system of equations. That is nothing but we have to find out whether they are intersecting, parallel, constant, or they are consistent or inconsistent. We have to find. So first question is, check check whether the given pair of equations represents intersecting, parallel or coincident. Yes. First question. 2x plus y minus 5 is equal to 0 and 3x minus 2y minus 4 is equal to 0. This is the first question. So here question is, check whether the given pair of equations represents intersecting or parallel coincident. There is nothing but you have to find out the nature of system of system of equations. That is whether they are parallel, coincident or intersecting. We have to find out by using the relationship between coefficients. So here in this case, if you observe the first equation, this is, here we have a coefficients 2, 1 and minus 5 is a constant, and seeing the second question, 3 is a coefficient of x and minus 2 is a coefficient of y, minus 4 is clearly is a constant. So now we take, if A1 is 2 and B1 is 1 and C1 is minus 5, and then A2 is 3 and B2 is minus 2 C2 is minus 4. C2 is minus 4. So now find out the A1 by A2. Find out the A1 by A2. So A1 by A2. A1 by A2 is 2 by 2. And similarly find out the B1 by B2. B1 by B2 is 1 by minus 2. 1 by minus 2. So clearly both the values are not equal. Both the values are not equal. So if both the values are not equal, you can say that A1 by A2 is not equal to B1 by B2. If A1 by A2 is not equal to B1 by B2, clearly they are intersecting. They are intersecting. So therefore they are intersecting. They are intersecting. So from this we can understand that they are intersecting at a point. So they have a unique solution. If they have a unique solution, we can say that they are constant pair of linear equations. Constant pair of linear equations. So clearly they are intersecting. Here we have to find out if they are intersecting or parallel coincident. Clearly they are intersecting. They are intersecting. Now let us do one more problem. So the question is here. Second question. 3x plus 4y is equal to 2. 6x plus 8y is equal to 4. 6x plus 8y is equal to 4. 6x plus 8y is equal to 4. So here in this case, the question is given like this. So we have to check whether they are intersecting, whether they are coincident or they are parallel. So first of all, we have to transform the given equations into a general form of the equations. So the first question can be expressed as 3x plus 4y minus 2 is equal to 0. And the second equation can be written as 6x plus 8y minus 4 is equal to 0. So this is equation 1 and this is equation 2. In the equation 1, the coefficients of x is 3, the coefficient of y is 4, minus 2 is the constant. And coefficient of x is 6 and coefficient of y is 8 and minus 4 is the constant. Now find out the A1. A1 is clearly 3, B1 is 4 and C1 is minus 2. C1 is minus 2. And A2 is 6 and B2 is 8 and C2 is minus 4. Is minus 4. Now find out the A1 by A2. A1 by A2 is 3 by 6. 3 by 6 is nothing but 1 by 2. And now find out the B1 by B2. So B1 by B2 is 4 by 8. So B1 is 4, B2 is 8. So 4 by 8. 4 by 8 is 1 by 2. And also we can observe that C1 by C2 is also 1 by 2. C1 by C2 is also 1 by 2. So here clearly A1 by A2 value is 1 by 2, B1 by value of B1 by B2 is also 1 by 2, C1 by C2 is also 1 by 2. So all the values are equal. In this case, A1 by A2 is equal, B1 by B2 is equal, C1 by C2. So hence we can say that they are constant. They are constant. So we know they are constant. Constant is nothing but both the equations are same. So in this case, the system of equations has infinitely many solutions. Now let us do the third problem. One more problem. So third problem is check whether the given pair of equations represents intersecting or parallel constant. Same. So x minus y minus 1 is equal to 0. X minus 2y plus 2 is equal to 0. Plus 2 is equal to 0. So clearly there are general form. The general form the linear equations into variables. So now question is whether the system of equations or the two lines are they are parallel or coincident or intersecting at a point. So in this case, tell a1 is 1, b1 is minus 1 and c1 is minus 1, and then a2 is 1 and b2 is minus 2 and c2 is 2. C2 is 2. So now then we have to find out the a1 by a2. So a1 by a2 is 1 by 1, 1 by 1 which is equal to 1, and then b1 by b2. So b1 by b2 is minus 1 by minus 1 by 2. Minus 1 by minus 1 by 2 is nothing but 1 by 2. And then c1 by c2 is clearly minus 1 by 2. c1 by c2 is minus 1 by 2. Minus 1 by 2. So a1 by a2 is different from b1 by b2. Both the values are not same. Both the values are not same. So therefore a1 by a2 is not equal to b1 by b2. a1 by a2 is not equal to b1 by b2. So if a1 by a2 is not equal to b1 by b2, they are intersecting. The two lines are intersecting at a point. Hence the two lines are intersecting. The two lines are intersecting lines.